So our next speaker is Milecia. She's a senior software engineer. She has a master's degree in mechanical and aerospace engineering, and she has published research in machine learning and robotics. Wow. She's also started Flipped Coding to teach people how to code with real-world projects. Today, she will speak us about the top 10 attacks you can have in a Node.js application and how to handle them. Hello, how are you?
I'm good. How about you?
Quite good. What time is your time zone right now?
It's 7:30 a.m. where I'm at right now.
Okay, thank you for waking up so early for us.
Yeah, no problem. I'm glad to be here.
Yeah, I'm very happy for you to be here as well. So thank you again, and see you in a bit.
All right. Hi, everyone. My name is Milecia McGregor, and I'm a developer advocate at Conducto, where we make CI/CD tools that don't use YAML. So, you can find me on Twitter and basically the internet in general at Flipped Coding, where you can ask me questions after this, or you can see the other cool JavaScript and not JavaScript tech stuff that I work on. But today we're going to talk about your security toolbox for Node.js. So I always like to start my talks with a quick overview so that you kind of know when you can tune in and tune out. But the first thing we'll talk about will be the OWASP top 10 vulnerabilities. We'll just go over a few of them that are a really common concern for Node apps. Then we'll talk about how you can handle your packages and dependencies to make sure that you're not exposing yourself to any additional risks that you don't have to. Then we'll talk about managing your data. So this will basically be how we talk about how to keep your data safe, how to make sure bad data doesn't make it into the back end, and all those fun things. We'll talk about protecting your server from different attacks and the tools you can use there. And finally, we'll just wrap up with a few key takeaways and some things that I really hope you can apply to your real work projects. So to get started with, let's talk about the OWASP top 10 vulnerabilities. You can find all 10 of them at the link you see on the screen in a really nice app. So basically, the OWASP top 10 accounts for the top 10 most common web vulnerabilities, and that covers everything from cross-site scripting to broken authentication to SQL injection attacks, and of course more than that. But basically, this is where you start your initial analysis for any apps you make, whether they're in Node.js or React or even PHP. But basically, these are the ones that I think on the OWASP site, it's like 60% of all websites are vulnerable to at least one of the top 10 security vulnerabilities. So go through, make sure you're a little bit acquainted with what those top 10s are. And as you write your app, you'll start to see those places where the vulnerabilities creep in. So make sure you go check out NodeGoat because it will take you through all of the top 10 vulnerabilities with a lot of explanations and examples. But we're going to talk about a few that are specific to Node.js apps. And the first one we'll talk about is cross-site scripting. So basically, cross-site scripting is when somebody can inject a malicious script, usually a JavaScript script, into your application and it executes. So the last thing you want is a hacker to be able to execute anything on your website. And the problem with cross-site scripting is that if they execute this attack correctly, it can affect your other users. So let's say, for example, they inject some script that when you click on a button or you click on a link, it redirects you to a different website. Maybe they're trying to fish for information by getting a user to put their credentials into this fake website. Or maybe they want to take a user session. They can do that if they write the right commands for that cross-site scripting attack. That's why this is one of the top 10 OWASP vulnerabilities, and it's also a really common one. You can go on any website that has a form and try to do a cross-site scripting attack. So that's why you need to know how to prevent those. And the way that you do that, which you'll hear this a lot throughout this presentation, first thing you need to do, if you aren't doing it, validate all of your inputs. So if you don't touch the front end at all, that's totally fine. Usually there's some front end work to validate inputs just to make sure users don't, save weird information, or they don't accidentally put a number where a string should be. But for those of us that work with Node, make sure that you're checking all of those requests that come into your APIs. Make sure that if you're expecting a name, you don't see a script. So again, validate all of your inputs. Any field that a person can type into, validate it. And then something else you can do to make cross-site scripting attacks a lot less potent, you can encode the data that you send to your users. So in this case, maybe somebody is trying to get some kind of response from one of your APIs using a cross-site scripting attack. That's possible, but if your data is encoded, it's going to be a lot harder for them to be able to get the information they're looking for. So one thing to keep in mind throughout all of this is that there is no application that is completely unhackable. What we do is try to make it take too much time and cost too much money for anybody to be able to realistically hack our systems. And that's why it's so important that you encode any data that you're sending to or getting from the server. The next attack, which you've probably heard of quite a bit, is the denial of service attack. And basically what this does is it makes your application completely unavailable to users. So what they do in a denial of service attack, usually it's a DDoS attack because it's a distributed denial of service attack. And that just means nobody anywhere can access this application. It's unresponsive completely. And a few ways that attackers do that would be just by overwhelming your server with a lot of redundant requests. Maybe they have maybe they've done a cross-site scripting attack and they're just running a loop to keep requesting the same endpoint over and over until it just slows your entire system down and nobody can access it. Or maybe they're trying to upload a bunch of data to the database, and we all know how slow that can be sometimes. And if it's happening in a loop, or it's just happening in one big push, that can completely render your service useless. Nobody will be able to use it because all of the threads are running at 100%. But in Node specifically, there is one vulnerability you need to make sure that you're aware of. When you're working with those really, really complex regexes, sometimes somebody can make an attack to take advantage of that and do a DOS attack, which basically means that they'll use that regex to keep evaluating these ridiculously long, complex strings. And sometimes that's enough to hang up an application. So be aware of those regexes that we have to use in our endpoints sometimes. Those are very specific to Node.js applications when it comes to the denial of service attack. But of course, there are some ways that you can prevent these kinds of attacks, and they're not too much different than the ways we'll prevent a lot of other attacks. But one of the first ways is to make sure you have some kind of system in place that will prevent any looping and data creation at the same time. I personally haven't seen very many apps that need loops to create data. So if you have anything in your code that does that, you might want to take a look at it and see if you can refactor it to something else, just because this is an extreme vulnerability for your application. Cross-site scripting is bad, but so is denial of service. You don't want users bogging down your support team just because somebody attacked your system and you weren't prepared for it. That's why we put these checks in place to make sure if there are any loops that they only execute under certain conditions. If there is data creation, it has all of that nice form validation, which I told you, this one is going to come up a lot throughout this talk. Validate all of your inputs. Just do it. It's one of those, I know sometimes checking types when you're trying to get new features out the door can be a little bit tedious, but to prevent two kinds of attacks so far, it's really worth the extra effort. Because like I said, the front-end team, they're probably already doing some kind of form validation, but for us on the back end, it's always important just to double check because we're responsible for what gets to the database. The back end is like the gatekeeper. So make sure that all of the information you're getting has been validated and sanitized to prevent any weird values. Next, we'll talk about the server injection attack. And basically, this happens when untrusted data gets injected as part of a query. So this could be something like a SQL injection attack, where basically they try to either query your database just through the front end, or they try to completely drop your database. So you never want a successful server-side injection attack to happen, because this is usually what they're talking about when it comes to those huge data breaches. So when a company like, who was one of the big ones, Experian? I think it was them a few years ago. When a company like that is, well, theirs was worse because they just had the default admin credentials. But in other cases, there are times where an application will just accept random commands from anyone and a database will get dropped, or all of the information will get shipped to the person that performed the injection attack. So a couple of ways that this could happen is if you're using an eval method anywhere. So basically this can make a response call and read users' data. So you can go ahead and make your backend call like normal, and it'll return the user data to someone that is not the user. So of course we don't want those to happen, but there are, again, a few ways to prevent this. So one of the big things you can do, especially on the Node.js side, is use json.parse when you need to parse user input. So you might have some kind of homegrown parser or something else that you're using, but you really want to make sure that this data gets parsed correctly, because if you're just sending unparsed data anywhere else in the application, there is a very strong chance that there's some code in there or some extra text in there that shouldn't be, and it'll cause problems for all of your users later when they can't log in or access anything because all of the accounts are frozen. Which also leads to validate all of your inputs. Again, I told you this is probably the most important thing you'll have in your toolbox, is knowing to validate all of your inputs. It doesn't matter if you're used to whatever the front end sends, if you think that they've got it covered. They probably do, but it's your job to make sure that you have the back end covered just in case something happens, stuff happens. Maybe a regression on the front end happens and all of the form validations are gone. I've seen it. I've been the one to fix it, so I know that that is a possibility. But on the back end, just make super sure that all of the data you're getting from your requests are validated. So now we'll get into some of the more fun parts of the toolbox, handling your packages, because I know we all miss those days where we could walk on the other side with our bags. But one of the big things to keep in your toolbox is to know to maintain all of your dependencies. So patches for different security vulnerabilities are released all the time. There's just different attacks that come up over the months and years, and we have to fix them. So that is one of the things you should really be aware of when you're working with packages, is that they are on top of their security patches. Because if they aren't, that leaves your application open to that kind of attack. And then, of course, we have a few things that we can do to make sure you're maintaining your dependencies correctly. Run npm audit and don't ignore the results. I know sometimes it's easy to do that just because we're kind of used to seeing errors and red sometimes, but when it comes to your packages, just take the extra time to run an audit and actually look at what's wrong. You might be surprised how many high-risk vulnerabilities you have compared to low risk. And then something else, there are a lot of packages out there that just aren't maintained anymore. You need to make sure you aren't using those because they will have security vulnerabilities that just aren't being addressed by anyone because nobody's maintaining them. And of course, there's also an easy command to check for any outdated packages. npm outdated. Who would have known? This will give you a list of all of the packages in your project that are potentially outdated, and you should look at them. Usually most outdated packages have some kind of newer alternative, and if not, you might consider pitching an idea of making a homespun version of it. Then something else with your npm packages, like the ones that you specifically make, manage, and own. As much as we all love two-factor authentication, it is really great for security. So I know that we hate using those two-factor apps and getting the text message and email, but it makes it a lot harder for somebody to get access to what you're working on. And then, when you set up your packages in new applications, go ahead and just get a different read-only token for each one. npm has it in there somewhere where you can get your tokens to authenticate your different applications. And a lot of times these read-only tokens are just used in your CI/CD pipeline just to get like all of your services and packages ready for production. Now we can talk about managing your data, because it is about as interesting and confusing as this picture. It all swirls into a vortex eventually. But you want to make sure that you're validating and asserting types on your data. And that means your data is pre-sanitized to prevent any type of bad stuff coming in. So I know I've mentioned this a lot, but validating all of your inputs is really that important. When you have certain types and certain things that you're expecting from a field, it makes it a lot easier to catch those values that aren't a part of anything. So just take the time up front and type your schema. This usually happens on the database design side, but make sure you have the models that reflect it on your backend side. So even though you know what you're getting from the front end and you know what you're saving to the database, having that extra typing on your schema just makes it impossible for a different value to be saved in that particular field. This is how you stop attackers from really wreaking havoc on your database, from being able to change values, and just generally from making your app weaker than it has to be. So just go ahead and add those types to your schema. Make sure your models account for all of the fields that you're expecting. Delete any model fields that aren't being used anymore, because every now and then there might be a clever attacker that figures that out, and then they use that unused field to make some kind of weird data manipulations that mess up things for users later. And if you don't want to go through the trouble of making some kind of homemade version for validation, you can try validator.js. I don't have any association with them, but I think it's a pretty cool library to use. It just makes it easy to check for things like emails or zip codes or those common fields that you see on every website. So just keep validator.js in mind if you want to make sure you validate all of those inputs. Then for requests and responses, I just have one really cool tool. If you are a Node developer and you haven't seen Helmet.js, that's understandable. But basically Helmet.js adds like 12 HTTP headers to every request, which adds such an extra layer of security that it's almost crazy how simple it is to use Helmet.js. You know, when you have the app.use lines throughout your Express apps, Helmet.js is basically just included in one of those, and it automatically adds all of these security headers to every single request that comes in and every single response that goes out. So if you're looking for a tool that just automatically does stuff for you and all you need to do is put in one line of code, Helmet.js is where it's at. This is probably the easiest tool in this toolbox to implement. So just keep that in mind for later if you need a really quick, impressive upgrade to your Node security. And when you're handling user data, we mentioned it earlier about encoding it, but you can keep everything encrypted from response to request with Crypto.js. This is a really, really good library that's well maintained, and it's used for things like Pixie authentication and sometimes some proxy handling stuff. So Crypto.js is really powerful with the encryption tools that it comes with. And it's another one of those, it's really not that bad to integrate because you only use it in a few places with a few different method calls. Plus, the documentation is really good too. Next, we'll talk about how you can protect your server, because we need a guard in front of our servers to make sure that no cloud entity ever touches it unless it's us. First and foremost, you should be using HTTPS. If you're not using HTTPS, do it now, because why are you not using HTTPS in production? So use HTTPS. If you aren't, you'll probably see that bad looking message on Google and in Firefox, and users might not even be able to access your application unless you're using HTTPS. This just gives you that extra layer of encryption to make sure that even if data gets hijacked, it's a lot harder to crack. It'll be encrypted. They'll have to figure out which method to decode with, and the odds of them doing that are pretty slim, just because cryptographic stuff is random. So something else with your server, you want to do some rate limiting. And basically what rate limiting does is it makes sure that your server doesn't get overwhelmed with requests. So it limits the number of requests and responses that can be handled through your server. And one of the tools you can use for this is Express Rate Limit. And it's another one that's super easy to set up and get using. It has some great docs, but basically you just tell it, hey, don't process more than this number of requests in this amount of time. And it just does it for you, which is great. I love it when packages just do things for you. And another one you really want to watch for is cross-site request forgery. This is basically when an attacker gets access to a victim's browser and they start sending requests acting like they're the victim. So basically what this does is it lets an attacker forge their online identity to be that of the victim. And what this does, it gives them access to everything that the victim has access to. So say, for example, one of your site's admins gets hit with this kind of request forgery attack. That means the attacker could have access to everything. They could have access to other users' records. They could have access to some of the more delicate features of the application, like toggling settings and switching other users' permissions, and just a lot of stuff that they can take advantage of, and nobody will know it was an attack because it will look like it was the victim doing all of it, because their ID, their auth tokens, all of their credentials are getting used to make these requests. So one thing you can do to try to prevent this is add csurf.js to your project. This is another one. It's just a quick security tool that will protect all of your API endpoints from this kind of attack in particular. And again, it has some great documentation, and it doesn't take a whole lot of time to get set up with. So now that you have your whole toolbox and you're ready to go shape up your Node application, there's just a few things that I want you to take back with you. Use the tools that are out there. You don't need to make a new security tool all the time. You don't have to go through the hard process. There's so many open source tools out there now that what I've mentioned just scrapes the surface of the popular tools. Those aren't even all of the popular tools. So just look around and see what works for you the best. And of course, don't wait for a security breach to validate all of your inputs. But really, don't wait for a security breach to happen before you start implementing security into your Node app. And then Node honestly makes it pretty easy to handle any of the OWASP top 10 attacks, just because of all of the support and the different libraries and the way that it's set up. Node just makes it easier to make sure that those main threats don't happen to you. And then if you're really curious, just take a look at some of the tools attackers are using. If you want to see like a real attacker toolbox, check out the Kali Linux OS. It has a lot of open source hacker tools that'll give you an idea of what they're actually using when they try to attack your website. So hopefully you were able to learn something from this talk and you've added some new tools to your box. But if you have any questions, I'll be around after this talk. And if you don't find me there, you can always reach out to me on Twitter at flippedcoding, because I actually check my DMs and my tweets and whatnot. So I hope that this was informative for you and it'll make your job easier later on. So thank you.
Hello, here we are. Well, thank you a lot for your talk, Milecia. It was very interesting. I'm fairly sure that as soon as the conference ends, all the attendees will go take a look at their code and apply your recommendation. I definitely think that don't wait for a security breach to fix your code. It should be appended in every new wall, in every office around the world. Please do that. And a question that I want to ask you. So I completely agree with you that validating inputs is always important, as you shown us, is basically you will solve at least half of the problems you can get, which is already a lot.
Mm-hmm.
Other than validator.js, do you recommend any other libraries for doing this?
What is it? React Final Forms has some really good built-in validation. Other than that, there's not really any tools that I've personally used.
Okay. I know that in the Node community, Joy is very widely used for validating incoming requests. So basically for validating the shape of the objects, and which is very nice. Usually what I do is to write JSON schemas. I use JSON schema validators, which basically is the same concept as a validator.js, I think. But hopefully it should be a bit faster, so you don't sacrifice too much performance for validating the request. And a question that I wanted to ask you is, so let's remember, like in the last 3-4 months, most of the security issues I saw in my code were about development dependencies. Should we care also about development dependencies issues, or can we just skip them or take care about them later?
Honestly, I don't want to say skip any of the security problems. Like, I know we get tired of the dependabot messages from GitHub, but it's really important that we update those packages just because it's a noted security vulnerability. That means anybody who has any kind of malicious intent, they can just go look at that report and see exactly how to take advantage of that weakness. So if there's any of the packages that you have that are going to prod, then yeah. But if it's just stuff you're using locally, you can be a
Better
little
safe
bit
than
looser.
sorry.
Yeah.
Okay. We get a question from the audience, which is, it is better to implement a rate limiting at the reverse proxy level instead of using a Node.js library, or whatever. Which one do you recommend or prefer?
A reverse proxy isn't a bad idea just because it gives you that extra layer of security that people can't directly access your server, but I'm not sure. I guess it depends on how you set it up, if it'll affect performance at all, just because, sending a request through something else to get to something else always slows it down a little. But I don't know. I think a reverse proxy is also a good security implementation.
Yeah, thank you for your answers. So how will you normally start a security audit of any application?
So usually I start by making some kind of threat model. So maybe we'll look at the OWASP top 10 and pick the main, I don't know, 3 to 5 that we're pretty sure our application would have. And then from there, I'll go through and do things like use different security tools. If you're familiar with Sneak or what's another one? Sneak or Arachne, I believe, Core OS. Those all run static security tests on your code, kind of in the build phase of your CI/CD, but they check for things like cross-site scripting and SQL injection attacks and those vulnerabilities that we all kind of ignore. But that's usually how I go through and initially check for any security vulnerabilities. Just look at that OWASP top 10 and use some of those static security code tools.
Okay, thank you. I guess also it probably depends on where your server lives. Is it something internal only, or exposed to the public. I guess also that really depends on the situation. So there are other security precautions you recommend to be taken. Let's say that we went through all the top 10 security list. We feel safe, but we want to do more. Is there something you would like to recommend?
About the only other thing I would recommend as far as security is to make sure that you have good monitoring and logging tools. That way you can catch those abnormal requests really fast. Like if you have a monitoring tool that checks for anytime somebody puts maybe JavaScript into an input box, you can go through and make sure that you're not allowing any cross-site scripting attacks or any of those other things.
Sorry about that. Yeah. He had an opinion as well about this, apparently.
Yeah, I have to. I'm surprised they're this quiet right now.
Yeah, it has been super quiet the entire morning. I don't know why now he decided to have an opinion, but you know. Okay, well, I don't think there are any other questions from the audience. So thank you a lot again. It was very interesting, especially useful for everyone who's working for both front end and back end, especially back end in this case. So thank you a lot again. See you later.
All right. See y'all later.
Cheers.